Hello, this is Mr. Henry, and welcome to Lesson 1.3, Integer Exponents. This central question says, how do I use properties of integer exponents to simplify expressions? So we have the next couple lessons here are going to be all about exponents for the most part. We've got this lesson on integer exponents, learning the properties about them. The next lesson is on square roots and cube roots, which is basically doing the reverse of an exponent when you're solving an equation. And then in 1.5 we have scientific notation, where we're using exponents in a new way, an application of it. All right, so down for our warm-up in the Collins writing page in front of your packet, this is lesson 3. It is a type 1. It says, what do you know about exponents? You can draw a picture, you can give an example, you can write out in words. Just what do you know about exponents? And also, can you think of an example of when they're useful? And again, as I said, the most of this lesson, the next lesson, and the one after that, the rest of this module, are going to be about exponents and why they're useful. But so can you think of an example of when they are useful? Go ahead and pause the video, answer this question. When you're ready to continue on to the vocabulary, hit play, and we'll move on. So here we have our vocabulary: power, base, exponent. So the power is the entire thing. It's the base and the exponent together. So the entire thing, if I would write out that, this whole thing together is called a power. Now, the base would be the bigger number that's on the bottom. So in the example I put up there, the 2 is the base. So the power is the whole thing. I'll use that same example. The base is the 2. And you can probably guess that the exponent then would be the 5. It's the little number on the top. So just kind of getting us into the lesson a little bit here, let's look at some different properties. So we're going to start by looking at properties. We're not really doing many problems of applying them. We're just looking at what these properties mean. So the first property here is we're trying to understand the product of powers property. The product of powers property, what that means, like the title, the name means, is we're multiplying powers together. So we have two powers like you see. You'll notice they have the same base, 7 and 7. So we're going to multiply these two things together. Now the way that I would think about this problem is if you would take this, 7 to the 4th power, and you would expand it. 7 to the 4th power means 7 times 7 times 7 times 7. That's the first part. Times this 7 to the 5th power. So 1, 2, 3, 4, 5. So that's what this same problem looks like if you expand it out. You've got 7 to the 4th power times 7 to the 5th power. But since these are all multiplies, multiply, 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 all we have to do is just think about this one long line of 9 different 7s being multiplied together, which is 7 to the 9th power. So we just simplified this exponent. So 7 to the 4th power times 7 to the 5th power is 7 to the 9th power. And there's actually a rule that can help us do this. The rule basically says if you have two exponents, we'll call it like a to the n times by a to the m. If you have two exponents and you want to multiply them together, two powers multiplied together, if the base is the same, you add the exponent. And that's what we did here. The base stayed the same, and we add the 4 plus the 5 and got 9. Okay. And we're going to go through these in more detail. So we're just going to start by going through each property kind of one at a time, and then we'll look at using them. So this is the product of powers property. Next property here is the power of a power. So another way to write this same problem would be 4 squared to the 6th. So the whole thing is to the 6th power. So you have 4 squared, and this 4 squared is to the 6th power. So you would have, if you would expand it out again, 4 squared times 4 squared times 4 squared, 6 of them. That's 4, 5, 6. So now we have this. But this is just like the last property we just did. We have a whole bunch of powers with the same base, so we know that we can add the exponents. If I would write this out even farther, there's going to be a whole bunch of these guys. 4 times 4 times 4 times 4. There's the first one. And the second one. 4 times 4. Third one. 4 times 4. Fourth one. 4 times 4. Fifth one. 4 times 4. Sixth one. But this line, after we've completely expanded this out, we just have 12 4s. 2, 4, 6, 8, 10, 12. 4 to the 12th power. Do you think you can find a connection between the answer we got here and the problem we started with here? Maybe you notice that it looks like we might be able to multiply 2 times 6 and get 12. And the answer is you can. That is actually the property in this problem. So if I use the variables again, a to the n times by, a to the n to the m gives you a to the n m. You multiply the two powers together. All right. So let's look at our next property.
All right, so this is the understanding the quotient of a power property. It's dividing powers. So 2 properties ago, when we were multiplying 2 powers together, when we had 7 to the 4th times by 7 to the 5th, when we multiplied the powers together, we ended up adding the exponent. Well, it's going to be just the opposite here. When we divide the powers, we are going to subtract the exponents, as you might have guessed. So, well, let's subtract the exponents. So you're going to take the top one minus the bottom one. So if we take 4 to the 5th over 4 squared, that's 4 to the 5 minus 2, the top minus the bottom. That gives us 4 cubed. Technically speaking, that 4 cubed is still on the top part of the fraction. Okay, that's one way to do this, is you know that if you have 2 powers like this, if they're being divided, you subtract the exponents. That's not typically how I do it, though. That works, but that's not how I do the problems in my head. Here's how I do the math in my head. I look at these and I go, okay, if I've got 5 4s on the top, 3, whoa, what happened there? 1, 2, 3, 4, 5, and I've got 2 4s on the bottom. There we go. Now, I'm going to start canceling. I'm going to start dividing. These are all being multiplied together. So if I cancel out 1 4 on the top and 1 4 on the bottom, technically what I have right here would be 4 to the 4th power over 4 to the 1st. But that's not important. Now, I'm going to keep going. I'm going to keep canceling. As long as I have one on the top and one on the bottom to cancel out, I'm good. And there I've done it. So now I have only 3 4s left on the top. So that would make this just 4 to the 3rd power on the top with nothing down below. And typically if you have this over 1, well, you really don't need it. He just kind of goes away. So what would happen, let's say, if, side problem, if we had 4 squared on the top and, say, 4 to the 5th power on the bottom? Would it still be 4 to the 3rd power? No. Because again, the same thing. If I had 2 4s up here and I had 5 4s down here, 2, 3, 4, 5, and I start canceling these puppies out, you're gone, you're gone. 1 on the top, 1 on the bottom. Until I can't cancel anything else out, nothing else on top. So that means what's left over is, well, I have 4 to the 3rd power down here, and what's up top? Not 0, don't put 0, it's 1. So we have this 1 over 4 to the 3rd power. That is an okay answer. In fact, that's the correct answer. That's the answer we'd want to say here. Okay? So the way that I do dividing properties, or division of powers here, is I start canceling. I cancel, and I don't even write these out. I'm a big boy. I don't write them out like that. I kind of do this. I go, okay, if I got 4 squared and 4 here, so I'll cancel out 2 of these and cancel out 2 of those. So it'll be 3 left here and nothing left here. And you're going to find out in a little bit that anything to the power of 0 is equal to 1. So that's another way to get this. That, in the red, is how Mr. Henry does the math. It's not how you have to do it. You can write it out like this until you get comfortable. It's a new skill. It's okay to use crutches like this. But once you get going with this, you'll see that writing these out like this all the time kind of gets a little cumbersome. So having these little shortcut ways, just knowing you cancel, that can help you out.
Okay. Next problem says we're going to be understanding the negative exponent property. So in this case, the title itself is obvious. I mean, now we have a negative exponent, but what we would do is not so obvious. Now, the way that this works, or a way to think about this, is how a regular exponent, like 3 to the 4th power, represents multiplication. 3 times 3 times 3 times 3. But a negative exponent is going to think about it like it's division. They're kind of opposites. Positive 4 and negative 4, multiplication and division. So what this actually gives us, it's kind of weird. It's like 1 over 3 times 1 over 3, which in this case is just 1 over 3 to the 4th. Now this is just one way of thinking about it. It's not the only way. A way that I like to describe this is whenever you have a negative exponent, the way you get rid of that negative exponent is you pass it over the fraction bar. So let me give you another example. If we had 5 to the negative 6th, there we go. That way I can move it around. So we have 5 to the negative 6th. So if I want that negative to go away, I'm going to move it over the fraction bar. So this whole 5 and negative 6 comes down. Now, when I move this negative 6, or the whole term down, the whole power down, the negative goes away. Now it's 5 to the positive 6. And up top, we would have a 1. And that trick works forever. If I had a positive 6 down here, and I move the whole term up top, it would be a negative 6 again. Let me show you something else I made a few years back. So here I have a little flash activity I made just kind of show this procedure. So as I take this 5 to the 6th power, now it's positive 6, and it's on the bottom of the fraction, so think of this as a fraction bar. As I take this piece and I move it to the top, the exponent changed from positive to negative. And if I take any of these pieces, this x to the negative third, if I move it down, it becomes positive third. 8 to the negative 2, if I move it up, it goes positive. If I move it back down, it goes negative. So you can actually change the sign of the term you're using by, I say, moving it over the fraction bar, flipping it over the fraction bar. Okay, so the way we think about this in terms of our algebra, so if I have a to the negative n, for example, to make this not negative anymore, it'd become 1 over a to the n. So 3 to the negative 4th became 1 over 3 to the 4th. And the last, I think this is the last property for us to look at is the zero exponent. And this one's simple. The zero exponent basically tells us that if you have anything to the 0 power, if you have x to the 0, if you have negative 3 to the 0, if you have 97 or 19 to the 0, any number to the 0 power equals 1. Every single one of them. So a to the 0 power equals 1. And we can think about this with some of our other properties we used. For example, that first property we learned about. Imagine we had 3 to the 5th power times by 3 to the 0 power. Well, the bases are the same, so we would add the exponents. So 3 to the 5 plus 0 is still 5. So me multiplying by this 3 to the 0 power, that did not change my answer. It's almost like saying if I took 3 to the 5th power times by 1, I'm still going to get 3 to the 5th power. So that's another way to show this something to the 0 power is 1. Now, this chart here is just kind of to show some of these different properties. It doesn't show all of them, but it kind of helps you see a pattern. So we'll start here at 5 to the 1st power and work our way up. So 5 to the 1st power is 5. That's just 5 times 1. 5 to the 2nd power, 5 times 5 would be 25. 5 to the 3rd power, 5 times 5 times 5 is 125. 5 times 5 times 5 times 5 is 625. So you notice how we're getting bigger, bigger, bigger going this way. Going down, well, we just said that anything to the 0 power is equal to 1. And now we have negative exponents. We know that if we have a negative exponent, the way we get rid of that negative is we pass it over the fraction bar. So this becomes 1 over 5 to the 1st power and 1 over 5 to the 2nd power, which is 25, 1 over 5 to the 3rd power, which is 125. So we're getting smaller the more we go down. Another way I just thought of about thinking about this is every time you go one step bigger, you are timesing by 5. I mean, think about it. 5 times 5 times 5 times 5. Even starting down here, if you start at 1 over 125 and you times by 5, you're going to get 1 over 25 times by 5. Times by 5 times by 5. Going the reverse, going down, is a divide by 5. So 625 divided by 5, 125 divided by 5, divide, 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 divide. So that just kind of helps you maybe imagine or picture these exponents in your brain to help you when you're doing some of your problems. Now, up in your vocabulary box on the right-hand side, there's a section for these properties, and I'm going to just give them all to you right here.
All right, so up in your vocabulary box, next to the 3 vocab words, power, base, exponent, you'll see a little box off to the side. So this is essentially just now a cheat sheet for the 5 properties we looked at. We have the product of a power property, where if you have 2 powers that are being multiplied together, like this, you add their exponents. We have the power of a power property. If you have a power that has an exponent, then you multiply the exponents together. If you have 2 powers with the same base that are being divided, you subtract their exponents, or when we did it, we did the canceling. We figured out that if you have a power with a negative exponent, you take that negative exponent and you take the whole power and you pass it over the fraction bar, move it to the other side of the fraction to change the sign of the exponent. And then finally we figured out that anything to the power of 0 is equal to 1. So there's a little cheat sheet that you can keep referring back to as we're trying some of the problems throughout the lesson, homework, all that kind of good stuff. Alright, so let's look at some problems. The directions here say simplify each expression, and answers should be expressed with only positive exponents. You'll see that a lot. The fact that you only want your answers with positive exponents. It's kind of one of those things you do with exponents. Kind of like when you have a fraction, you always simplify the fraction. Well, when you have exponents, you always want them to have only positives in your final answer. Alright, so my first expression here, when I look at this, I see 2 parts. I see this part here is being multiplied to this. But I can't do anything with the second piece yet. He has to be combined with the first. So in order to do that, I have to simplify this first part. Okay, so this was one of our expressions, one of our properties we looked at. This was the power to a power. And if you have one power being multiplied by another power, you multiply their exponents together. So this would become 6 to the 8th power. We multiply. Okay. And now that I have my first part done, now I can move on to the second step. I'm going to throw a little X in here. Maybe that'll help me remember that I multiply those powers together. So now here, I'm going to see 2 powers being multiplied together. I'm going to add the exponents. So this will become 6 to the 8 plus 3 is 11. Something I remember seeing before that might help you with a problem like this first one here is something I looked up. The abbreviation is PMA. It stands for power, multiply, add. So essentially, if you're looking at a problem, so I'm going to look at this first problem again. Maybe this will help clear some things up here. If you look at this first problem again, so here I have a power to a power. So I'm going to, since I have powers, I'm going to multiply those exponents together. Again, that's 2 times 4 is 8. Okay. Now this could be a separate problem or just in this problem. Now I look here and I have 2 powers that are being multiplied together. And so I'm going to add those exponents together. I end up getting the same answer. It's just this PMA is kind of a way to help organize your thoughts, how to remember these properties a little better. So I'm going to try to use this a little bit here throughout the lesson. I know you'll be using it in the collaborative project for this lesson. But let's continue on. Letter B. So letter B says 3 to the 4th power m to the 5th all to the power of 0. So, I mean, we could, since this is a power, all of this is to a power, we could use this multiply. We could multiply those exponents together and multiply those exponents together and get 3 to the power of 0, m to the power of 0. And you go, okay, well, is that it? No, because we had that other property that said anything to the power of 0 is equal to 1. So essentially, this is just 1 times 1, which is 1. This whole thing simplifies down to 1. And actually, we could have done that right from here, because this whole thing is to the power of 0, and anything, if I just go like this, and you don't even see what's in there, if I say I have something that's the power of 0, you're going to go, hey, that equals 1. Then you're right, it does. Okay, letter C. Okay, so this is that division of powers. So the way that I would do this is I use that subtraction, or I use that canceling. So in my head, I don't usually write this out. This is an in my head step, but I'll write it out for you. I've got 4 3s on top, and I've got 2 3s down below. So in my head, I start canceling out. I cancel out 2 on the bottom and 2 on the top. Or if you don't do this part in your head, just go, okay, cancel, 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 cancel. There'd be none here. There'd be 2 here. And so what's left over in the end after this canceling is you'd have 3 squared up top, 2 3s up top, or 2 3s there, and you have no 3s down here. So you could put 1, because 3 to the 0 power is 1, or since it's on the bottom of the fraction, you can kind of just leave it out. So we can leave it like that, or we could just make it 3, yeah, just 3 squared. Alright, so for our last problem. Well, now these guys have different bases. Here, the bases were the same, so you can do this subtraction thing. Here, I've got a 5 to the 6th power and a 7 to the negative 6th power. I cannot subtract those bases, or I can't subtract the exponents. But what I'm going to do is I'm going to take this piece and move him to the top of my fraction. I'm going to get rid of that negative. So if I move that guy to the top, let's get rid of this one. Then what I'm going to have is 5 to the 6th power on top, a 7 to the 6th power on top, and nothing down here. So I can essentially ignore this over 1. Okay, and now I've got this. And truth be told, we really can't do anything with that. That's done. I got rid of my negative exponent. Those do not have the same base. They don't have the same number on the bottom. That's a 5 and that's a 7. So I'm done. Alright, so here are a couple problems for you to try on your own. So these are the same ideas as the first 4 we did, just more examples of them. They might look a little harder, but they're really not that much. So go ahead, pause the video, try them on your own. When you're ready to continue, hit play, and we'll go through them together. Alright, so first one here. looking at a couple things, I see a bunch of parentheses. So I've got this 7 to the power of 0, and this 7 to the power of 0 is being multiplied by this 2, and then all of that is being raised to the third power. So kind of like order of operations, we got to work inside the parentheses a little bit. We want to worry about this stuff in here before we worry about him outside. Okay, so, well, what is 7 to the power of 0? Well, anything to the power of 0 is 1, so that guy's just 1. Looks so much pretty already. Now we can pretty this up even more. 2 times 1 is just 2. Even prettier. And that's done. 2 to the third power is my final answer. If the problem said evaluate, which means to actually find the answer, to do the math, we could say this 2 to the third power is equal to 8. 2 times 2 times 2. But these just say simplify the expression, so we don't need that. Okay. Letter F. 6 to the third power over 6 to the fifth power. Well, the way that I would do this is I would start canceling. I've got 3 6s on the top. Again, I'll write this out for the folks that need it. 3 6s on the top and 5 6s on the bottom. And if I start canceling, I've got cancel 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom. And what's left over, after all my canceling is done, I have 6 squared on the bottom. I've got 2 6s on the bottom, and there's nothing up top, and we don't put a 0, 1. There's always technically a little invisible ghost 1 at the end. Now, without showing this out, the way that I would do this is I would say, okay, I've got 3 on the top, 5 on the bottom. So if I cancel out 1, 2, 3 of these, 1, 2, 3 of those. So now I've got 2 down here, because 5 minus 3 is 2. And I've got nothing up here, because 3 minus 3 is 0. And then that is equal to that, and that is that. So that's how I would do the problem. Letter G. So, let's see, am I supposed to multiply those together, or am I supposed to add those exponents together? So let me think. We've got that PMA. So my exponent is to a power, so since it's to a power, I multiply the exponents. Okay, so I'm going to multiply these exponents, so I'm going to get x to the 16th power. Oh, that was easy. This PMA thing actually works. Okay, so last one here, letter H. So we have 4 to the third power times 5 to the 7th times 5 to the negative third times 4. So, well, I can actually do a little bit of rearranging. There's a property called the commutative property of multiplication that says I can move stuff around the way I want it to move. So I want to move the 4s together and the 5s together. That way I can start basically like combining like terms. I can start doing the math of the stuff I'm allowed to. So if I move this 4 out front, times by 4 to the third power, times by 5 to the 7th, times by 5 to the negative third. And you're going, Mr. Henry, you dropped all those parentheses. Why? Well, they really aren't needed. They're just showing multiplication. They're showing this thing times this thing times this thing times that thing. So I just wrote it out without the parentheses. Maybe that's easier for you. Okay, now let's see. My 4s here. My 4s are being multiplied together. So since they're being multiplied together, I'm going to add their exponents. Okay, so 4 to the... Well, there's 3. How many does he have? Not 0. If he had 0, this guy would be equal to 1. So he has 1 exponent. Anytime you see a number without an exponent, 1. So now this added up gives me 4 to the 4th power. Okay? Now my 5s. 5 to the, let's see, same deal. These guys are being multiplied together, so I'm going to add their exponents. So I'm going to take 7 plus -3. You might have done the math in your head already and know that that answer is 4. So I have as my final answer 4 to the 4th power times by 5 to the 4th power, and I can't do anything else. Those bases are different. I have no negative exponents. I'm done. Alright, so in the next couple problems, we're going to start checking out some applications of these exponential properties.
But let's look at some applications. It says the side lengths of a square are x to the 3rd power feet long. So let me draw myself a square here. So each side is x cubed feet. The formula to find the area of a square is area equals the side length squared, where s is the side length. Okay, length of each side. Write a simplified variable expression for the area of the square. So they're not actually telling us what x is. They're not asking us to find it. They want us to write a simplified variable expression. So the side length of my square is x cubed, and that side length is squared. So I'm just going to simplify this. And a power to a power, I just multiply the exponents together. That gives me x to the 6th power. And that one's pretty easy. Next says, the volume of a cube can be found using the formula v equals s cubed. This sounds very similar to the last problem. Okay, so let's see. We got ourselves a cube. Boom. Okay, and volume formula s cubed. All right, cube A has side lengths of 5 squared centimeters. So each side is 5 squared centimeters. Cube B has side length 3 cubed centimeters. So 5 squared, 3 cubed. Okay, write the ratio of the volume of cube A to cube B. So the first thing we have to do is, if they want a ratio of the volumes, meaning I want to have volume of cube A over volume of cube B. This is the ratio that they want, right? The ratio of the volume of cube A to cube B. I need this as my final answer, except I need to know what those volumes are. So for cube A, the volume for cube A is going to be side length cubed. I'm just writing down the formula. And we know each side is 5 squared. So the volume of cube A, see, 5 squared cubed, you multiply those exponents, giving me 5 to the 6th power. Okay. I'm not sure if I need to go farther than that yet or not. Let's start with B. Volume of cube B, same thing, same formula. So we're talking about volume. And 3 to the 3rd to the 3rd. So volume of B is, I multiply my exponents together since it's power to a power, 3 to the 9th power. And I suppose since we've haven't been really multiplying out our exponents yet. I don't think we need to in this problem. So I'm going to say my ratio here, if I actually just substitute my values in here, the ratio of volume of cube A is 5 to the 6th over the volume of cube B is 3 to the 9th. So there is my ratio of the volume of cube A to cube B. Volume of cube A, volume of cube B as a ratio. Volume of cube A, volume of cube B as a ratio. And I'm done. I would like you to try this problem on your own. Please pause the video, try the problem. When you're ready to continue, hit play, and we'll go through it together. Okay, it says the ratio of two drill bits is 4 to the negative 5th power. What is this ratio using only positive exponents? Okay, so 4 over 4 to the negative 5th. So the first thing I'm going to do is I'm going to take this whole piece and I'm going to move it to the top because I want this negative exponent to become positive. So that's going to give me 4, and this guy goes up top, so 4 to the 5th. And down here, I would just, honestly, I'd have 1. That would be what's on the bottom of the fraction. But if you ever have a fraction just over 1, you really don't need that bottom part. This looks like it can simplify even more. That's 4 to the 1st power and 4 to the 5th power. They have the same base, but different exponents. So I can add the exponents together. So 4 to the 1 plus 5 gives me 4 to the 6th power. Here's one more for you to try. It says your friend is trying to simplify the expression 5x squared to the negative 4th power. Explain to your friend how to simplify the expression using only positive exponents. Be sure to explain when you are using a property. Okay, so go ahead, pause the video, do the problem. When you're ready to continue, hit play, and we'll go through it together. Okay, so here's what I would do. I would probably, well, I guess let's just start. 5x squared negative 4th. First thing I would do is we're going to have to multiply these together because I want to get rid of these parentheses. So I'm going to take my 5x squared to the negative 4th, which is going to give me 5x to the negative 8. Now, something we haven't talked about a lot, this x squared to the negative 4th, we got that. I think that part's pretty clear. What you may not know is if you did this on your own, this 5 actually should be to the negative 4th power as well. You go, why? Why would you have to? Well, over here, the x is squared, so 2 times negative 4 is negative 8. But the 5 is to the power of 1, and 1 times negative 4 is negative 4. So this property we use to get here is the, make sure I have my name right, so when you have the exponent to an exponent, power to a power, there it is, power of a power property. So we used the power of a power property. Now, because we don't want any negative exponents, we need to get rid of them. So we want to get rid of negative exponents. So to do that, we're going to use the negative exponent property, which tells us if you have a negative exponent, if you pass it over the fraction bar, it becomes a positive exponent. So there's my fraction bar. So I'm going to get 1 over 5 to the 4th times x to the 8th, and that is the negative power property. Or is it negative exponent? Negative power. The negative exponent property. And I think we did everything we needed to do. Let's see. It said, your friend is trying to simplify the expression. Explain to your friend how to simplify the expression. Using only positive exponents, check. Be sure to explain when you're using each property. So we use the power of a power property to get rid of the parentheses. We want to get rid of the negative exponents. We use the negative exponent property to move the powers on the bottom, and they become positive. Alright, so for our summary, this again is on the Collins writing page in front of your packet. This is lesson 3. It is a type 1. And let's make it like 2 minutes instead of 1 minute. Questions are, what property do you find the easiest? So out of the properties we learned today, what property do you find the easiest and why? And then what property do you find the hardest and why? This just kind of gets you to reflect on your own learning here. So go ahead and answer these questions in the Collins writing page in front of your packet. And when you're done, that's the end of the lesson. This has been lesson 1.3. Thank you for watching. Goodbye.